All right, exponential growth and decay. 3,2 means nothing. It was in a, that was what the section number was from something somebody made up, so it really doesn't matter. But we already know in general what exponential growth and decay looks like. So exponential growth occurs when a quantity exponentially increases over time. It would look something like that. Exponential decay happens when it exponentially decreases, which would look something like that, right? So here is our functions. So our function, and we're going to write it in function notation. Sometimes you might see it as y equals, or they could use other letters, and we're going to use t as our variable and not x. So this is going to be f of t equals a. So, and then it tells us a is the initial amount. You know, I'm going to put $1,000 in the bank or whatever. That's your initial amount, or your principal, sometimes that's called. And then we multiply this by 1 plus r. R is the growth or decay rate as a decimal. Really, it could be a fraction as well. And then your exponent is t, and t is the length of time. Okay? 1 plus r, 1 minus r. And what that does, just so you can make sense of it, is, so let's say that you're going to buy something for $5, right? And there's 8% tax. One way you could find it would be take 0.08, multiply it by 5, that gives you your tax, and add it back to 5, right? Another way you can do it is take 5 and multiply it by 1.08, and that gives you your total. So that's basically what's happening here, 1 plus whatever the rate is. So you'd have over 100% when it's an increase. So when it's decay, it looks almost exactly the same. The difference is you subtract the rate. So again, if something is 25% off at the store, you could find 25% of the price and subtract it from the original. That works. Or if it's 25% off, you could just find what 75% of it is, and that's how much you pay. And that's kind of what's happening inside those parentheses. It's just different ways to look at it. So one of the things you want to pay attention to, and like I said, the reason that we're doing this, but we're going to start with just the basic ones, is that the ones that y'all seem to struggle on, which everybody does, okay, is when you have to take this t and you either multiply it or divide it by a number. And you usually know that you're supposed to, but then you get it backwards which way to go. Okay, so that's one of the things that we're going to work on. The reason that you have to multiply or divide has to do with the units in the problem. So basically, whatever the question is, you need to identify what t is. If it's time, is it years? Is it months? Is it days? Is it minutes? Like, what is it? So let's read number 1. All right, Brooke started her career. So she started her career with an annual salary of $64,000. Each year thereafter, her salary increased, that's important, we're increasing, by 2.5%. Write and use an exponential growth function. Now, and it tells you exponential growth. It probably wouldn't actually use the word growth. It'd probably just say exponential. Then you would have to know it's growth because of increase, but whatever. When she retires after 30 years. So, since it says that each year her salary is increased, t is equal to years. What?
32,000.
Huh. Okay, well, look at that. Okay, all right, well, hang on, let me do this then. Oh, you do have an extra one. Oh, yeah, okay. Either way, the number's wrong. Are these numbers right? Okay, so then that means what? Okay, so then I printed out an old one. I must have taken some questions off and then changed the number for some reason. I don't know, but I'll make mine 32,000, so. That's okay. That just means you're not going to have to do everything that's there, and you won't have quite as much room to write, unfortunately, but I think you'll be fine. Everything else is right there, the 2.5 and the 30? Okay, perfect. All right, so the t is in years, though. That's what we need to make sure we pay attention to. If I was going to have to multiply or divide that t by something, when this says each year, and they're giving me 30 years, those things would be different. Okay, like if it said each month and after 30 years. Now we can convert, but there's also other ways to do it. So that means I'm not going to have to multiply or divide t by anything. I just got to set up an equation. So we're going to say that f of t is going to be equal to our initial salary, which is $32,000. I have no idea why I changed that number. And I'm going to multiply it by 1 plus, do I add 2.5? No. What do I add? 0.0 times, yeah. Okay, so yes, 0.025. You don't have to put that first zero, and a lot of times I don't, to the t power. So it said write an equation. That is my equation. Notice I didn't use the 30s. Like this I could use, what if it was 30 years? What if it was 25 years? You know, it's one of the things my husband and I are looking at now. Like, what if I retire next year? What if I did this? So we have that. Then I can evaluate it at 30 years. And since this t I know is years, when I substitute in f of 30, this equals 32,000 times. Now, I could leave it like, if I'm going to put this in the calculator, I could leave it like it is, but I could also write 1.025 to the 30th power. Everybody okay with that? Y'all go ahead and get your calculators out. I should have told you that from the beginning. And I'll let y'all give me the answers, because last time I opened that calculator up here, it told me I couldn't use it anymore, so I give up. Like, I don't even know. Y'all are going to have to agree, because I have the other answers written down, but since I changed that number, that's what matches this. 67122. 67122. Okay, I'm sorry. Then point. Okay, so we'll do 16 cents since it's money. Okay, so that's her annual salary. So she starts with $32,000 as her salary. After 30 years, her salary is doubled, but it's still kind of small. Again, there had to be a good reason why I changed that, but I don't know why I did. All right, what questions we got? We good? All right, now, the other thing that just occurred to me was, first of all, that I don't know enough about TSI. On any of those practice, everything was multiple choice, right? I don't think you type anything in. But on the SAT now, you type stuff in, right? So if it's all multiple and you don't round correctly, you can usually find what the number is, right? But when you have to type things in, like to the SAT, if you don't know your rounding rules, that can hurt you. And luckily in AP, we don't have to round. We can truncate, and that's what we do, because some of y'all still, as seniors in high school, make up rounding rules that you will swear somebody taught you at some point, and if they did, holy cow. But we got to make sure we know how to round. So I'm saying that out loud so we can come back and make sure we know we don't do what I call the domino rounding, which scares me. So it just occurred to me while I was thinking about y'all rounding there. But this was 162 something, right? So it's just 1/6. That makes sense. Everybody go with that? All right, so let's read this. Kate drank an energy beverage with 150 milligrams of caffeine. Each hour, so that tells me that oh yeah, you can just cross out number 2. I don't even know what it was. It was probably a repetitive thing. Each hour, okay, so when it's explained like the rate and they're telling you it's hours and that's what it goes with, that's how you know what T is defined as. The amount of caffeine in her system decreases by about 12%. Write and use, and okay, then again, it says exponential decay. I should have taken that stuff out too, because the likelihood of them telling you you're doing growth or decay is highly unlikely, but hopefully you can figure that out. And then it says 1 day later. Now, this is different units. However, when you're converting hours to days, it's, huh? What the heck? Okay. I made those changes. Why I made them, I don't know. Probably so that we could look at it either way. Well, good. So if it's 8 hours, let's go ahead and leave it as 8 hours. because that will help us here. Well, no, it doesn't matter. It's fine. It really doesn't matter in this case. What I was going to say is if it is one day and those units are different, I could write it a certain way, but I also know how many hours are in a day. 24, right? So you could just use 24 hours instead of a day, but we'll use 8 since that's what yours says. I don't know. But it's been a couple years since I taught this, so. All right, so we're going to write, actually you try and write yourself an equation, just the equation, you're not using the 8 yet. Okay, write yourself an equation, f of t equals, let's see what we got. Okay, so our initial amount is 150 milligrams. We multiply that by 1, do I add or subtract? Subtract 0.12 to the t power. We all good on that? All right, so then I do f of 8, and that's equal to 150. Now, again, if you're using the calculator, you can leave it as 1 minus 0.12, but if it's a multiple choice question and they have the equation there, you would need to know that it's 0.88, but it doesn't really matter, and you can use it to the 8th power. Oh, good question. Why am I putting 0.12? Okay, because 12% is the same as 12 over 100. No, you're not. That's okay. 0.12. When you don't use things for a long time, you forget why you do things. It's okay. All right, so clearly the answer I have is going to be different than what you actually get. So can we agree on an answer? Somebody give me something. Not 0.9 what? 45? We agree with that? Okay. And then that is milligrams. Any questions at all? Even if you think it's a stupid question, it's all good. Okay. So I have a question. Y'all look at 4. Tell me if these numbers are the same as what you have. Now, 3 days, 50 grams. Okay. All right. So now this one has some extra information in it as well. So it's the half-life. This is important. Half-life of mercury 197 is 3 days. Okay. Does the 197 mean anything in the question? No. All right. Write and use an exponential decay function to find the amount of mercury 197, I don't care about that, left from a 50-gram sample after 20 days. All right. So these units aren't different, but we're still going to have to multiply or divide. So my t is in days, but it's technically happens every 3 days. So let's think about that. They didn't give me a percentage here, like 12% or whatever it was on the other one, but it's a half-life. What do you know what a half-life means from science? It's the amount. So if the half-life is 3 days, that means in 3 days, half the sample's gone. Okay, so it's going to be reduced by 50% in 3 days. That's what a half-life is. Okay, we good on that? Because that might be something we need to know. So that tells me this, that when I write my equation, so f of t, that's equal to, my initial amount is 50 grams. Okay? Half-life means it's going to be reduced by 50%, so it's 1 minus 0.5, or if you do just straight up half-life problems in science, you just know to put 1/2 there or 0.5, either way. And then I can't just put to the t power. This, if I just do, if t was days, and I just put t here, well, let's just go ahead and put one more, it's going to add something to it. If I put t there, and I had 1 day, that would be 0.5 power. But does it get cut in half in 1 day? No, it gets cut in half in 3 days, right? So if it takes 3 days and it's only been 1 day, how much of the time is that? Okay, so these 3 days it takes, this is multiplied by 1/2, right? Okay, that's what's happening there. But if it's only been 1 day, I get 1 out of the 3 days. So I would have to, this is why I would have to divide by 3 and not multiply by 3. And what I would suggest to you is write them both down and then ask yourself which one makes sense. If I put 3 times, y'all, I didn't do anything. 3 times t, because it's either going to be multiply or divide because of this. That would mean if t was days, 1 day would put this to the 3rd power. 2 days would put that to the 6th power. Does that make sense? No, it's going to be reduced. Y'all, good Lord, I swear I think this thing's haunted. If it's going to be reduced by 50%, I need this fraction to be 1. It would take 3 days divided by 3 to be to the 1st power for it to be reduced by 50%. Do you see how to think through that? I would suggest writing them both down and taking a minute to think through it, because I think you usually know, or especially if it's multiple choice, you'll have one that's multiplied and one that's division, and you don't even have to come up with 3. You just have to figure out which one is right. And so think about what it would mean when you substitute things in. Okay, so this would be our equation. If it's after 20 days, f of 20 equals 50 times 0.5 to the 20 over 3 power, which you definitely want to leave that for your calculator. And then you should get, because I think I have this answer down, 0.492 grams. Oh, little turkeys unplugged my fan. All right, did we get that? Make sure we know how to put it on our calculator. And I think, if not, I need to update these. Okay, I think I can update these. Did anybody's calculator when you did it to the, here, let me just try something. I'm sorry, I'm talking to myself now. But, because it just occurred to me, I haven't used these in forever. Where's the little carrot top? Oh, it's right there, I'm sorry. Oh, it puts it up there. Okay, never mind. There's some versions of that that'll put the exponent up there and some won't, but you can update the operating systems. All right, so back here, which I don't know if this is on, again, SAT or TSI at all, but E is something that is going to most likely come up in your college algebra class, and if you take any others or sciences that you take, E is definitely in there. So we're going to look at continuous growth and decay. Instead of it happening every month or every year, or every 3 days, continuous, when you see that, it means you're using E. Pi is 3.14159, right? E is 2.718, blah, blah, blah. You don't necessarily have to know that, but you need to know it's a number like pi. Sometimes it's good to know it's about 2.7 just for reasonableness of an answer. And I know you've seen this formula before, but I'm going to show you a short little video of E here in just a minute. So it says sometimes a quantity is constantly increasing or decreasing at an exponential rate, and not just year after year like I just said. And so this is what's called your PERT formula. So your amount is equal to your capital P, which is your principal, times E to the RT power. That's why it's called a PERT formula. So let me, well, I guess everything shut down a minute ago. I have the video, at least I did. Oh, here it is. It's just over here for some reason. But what I have to do is risk my life on a chair, unless there's somebody a lot taller than me. Jacob, you could probably reach. You taller than me? If you could just run your hand on top of that, there's not even a button. You just kind of, it's like magic, but it's like over here. Maybe go back and forth right there. Like press it. I know, there's no button, but that's what I usually do, and then it comes on. Okay, I'm here. I'll risk my life on a chair, it's okay. But if I fall, y'all don't leave me on the floor, okay? Yeah, there's no button. It doesn't make any sense. I can't find my remote. Okay. There we go. See, I don't know. And then I have to go back over here to turn the sound back up. All righty, here we go. What is the number E?
We've made a video about pi, the ratio of a circle's circumference to its diameter. But there's a less famous, but equally fundamental number known to anyone who's taken high school algebra. It's about 2.718281828459045, and so on. And it was first defined by Jacob Bernoulli, but later Leonhard Euler called it E, and the name stuck. Bernoulli first defined E through compound interest. Now, compound interest says that you get a little bit of money in interest every period, and that money you gained helps you gain even more interest next period. In other words, your interest compounds. So, if you stick $1 into a bank account with a 100% interest rate compounded annually, you'll get $2 at the end of a year. If it's compounded semi-annually, you'll end up with $2.25. Quarterly, and you'll end up with $2.44. Monthly, $2.61. Weekly, $2.69. See where we're going? If you increase the number of compounding periods a year towards infinity, then you'll get closer and closer to E dollars. In statistics, it describes the most important statistical distribution, the normal. In biology, it models populations of species through the logistic function. In physics, E describes the exponential decay of a radioactive material. So, while E may not be as famous as pi, it's easily as fundamental and immensely important.
All right, so again, and they showed you biology and physics and everything, and so if you take any other science classes, or those of you that took AP Bio, did you use anything with an E in it? Yeah, probably, and if you took physics, probably. So it's just kind of explaining to you where it's coming from. Now, we're not going to do, actually, we are going to look at a logistic function because they're just interesting, but, all right, so let's read this. This says, a garbage dumpster started with 4 pounds of garbage, okay? The amount of garbage increased continuously. So when you see continuously, that's when you know that it is your E function. By 35%, so you still have the rate from this point forward. Find the amount of garbage in the dumpster after 2 weeks. Okay? So we have that PERT formula. Your amount is equal to the principal, or what you start with. We start with 4 pounds of garbage. Okay, and this is a continuous function because it's not like people just walk by once an hour, it'll open, you can put trash in it. Like, it's just kind of a continual thing. 4 times E, the rate as a decimal, 0.35, times T. Now it says each day, and it says 2 weeks. So we could be fancy with what we do here, but if we just make T your days, we just make T days, in 2 weeks, how many days is that? 14. So when I evaluate A at 14, this is 4 times E to the 0.35 times 14 power. And then on your calculator, find E. It's under the natural log, which is next to 4. And go ahead and type that in. And we should get 537.159 pounds. Do we agree with that? Is that what y'all got? If your numbers are the same as mine? Okay. So that's your PERT formula. The good news is, on the SAT, they give you formulas like this, so I can't imagine that on the TSIA that they wouldn't. You know, you have a formula sheet for SAT, so I would think that you would have at least that stuff for TSI. All right, let's look at the next one. Population of a town is declining at a continuous rate of 25.9% every 2. Oh my God. What does yours say? Okay, we'll make that 1.5%. That's fine. And there's no 2 decades. Okay. Yeah. Okay, well then you know what? This question won't do what I want it to do anyway at that point. And I'm going to find better ones because this is one where we'd have to divide or something. And that's why I changed it. That's why it was this. We'll just scratch this one and talk about logistic. Because when I give you the other word problems that aren't the basic stuff that we have to divide and multiply more, we're going to do a couple more together. We'll just skip that. But I want you to look at logistic growth. Now, this won't be on the SAT. It won't be on the TSIA. I'm not going to test you on it, but I want you to think about what happens exponentially. So even here, this exponentially increasing the trash. And so this is heading to infinity, right? Is there actually going to be an infinite amount of trash in that dumpster? No. I mean, some things, even though it makes sense like around here in the graph, up at the infinities, it doesn't make a whole lot of sense. So when you're really applying this, if any of y'all are going into business or anything about like that, logistics is a big part of all of that. Because even if your sales are increasing exponentially, they're not going to go to infinity. Like that doesn't happen. So a logistic function is still using exponential stuff, and you're given this. You're not going to have to memorize it or anything. But notice how it is increasing exponentially, but then there is a limit to it. It's going to like kind of slow down and taper off. And that's what's happening here. So it says sometimes a quantity exponentially increases, but then levels out, approaching a horizontal asymptote. And for those of you that had Mrs. Archer last year, now I make fun of this to her face, so it's okay, we're friends. This word, asymptote, it's not asymptote. Who had Archer? Asymptote, right? I heard one of my students today say that, and I was like, I need to clear that up. It's fine. I make fun of her. Y'all can make fun of her, but I don't want anybody making fun of you. It's asymptote, not asymptote. Hello. Thank you. Asymptote. Right. Asymptote. And she's so cute when she says it. All right, so this is the logistic growth model, which C is where it's going to level out. And sometimes that's what we're looking for. But then it gives you all the other stuff. And this one's already all filled in for you because I just wanted to talk about what it might apply to. So if you look at number 7, and what's kind of a little scary about this is a question that I was doing like before COVID, and I remember reading this question like during COVID going, oh, maybe I should have chosen a different one. But a disease begins to spread in a town of 20,000 people. Okay, there's 20,000 people in this town, which is kind of small. There's 3,000 students in this school. So after T days, the number of people who've been infected by the disease is modeled by this function. Using the function, find the number of people infected after 10 days. Okay? So how many people, now, how many total people can get infected? 20,000. It can't be, I mean, it can be exponentially increasing, but we can't go past 20,000 because that's all we got. So that's why this is in the numerator there. That's what this is here. That y equals c, that's your asymptote, right? And that's where c goes. So I want you to type this into your calculator. Y'all know how to get a fraction to pop up before you start? Can you just hit divide on this calculator? Does it work that way? Just hit the divide. Nope. Okay. Well, I don't know. There's a way. So you need to do parentheses then. And then maybe I'll update your calculators. When you type it in, do 20,000 and then open your parentheses and type the denominator in. And hopefully you can read it on your paper better. Divided by. Okay, here's how we can figure out if your answer is reasonable or not. If you get something over 20,000, is your answer reasonable? No. Your answer, what you should get is 18,414 people. Is that not what you got? Or you just what? Because oh, that's because you didn't close your parentheses, maybe?
Oh, my bad.
Oh, and you put negative 0.25. You're making up numbers. Or is that what yours says on your paper? No, it's not. Okay, I was like, good Lord. It's negative 0.95. So make sure you can get the 18,000 number, because I'm pretty sure these are the same. 10 days, that entire town is sick. But it's going to start to, but if we did like 1 or 2 days, it would be a whole lot smaller, and then it, then it amps up. So I just wanted you to see what a logistics curve is. Did y'all do those? And who took AP Stats last year? Charles, did you? Did y'all do logistic curves at all? Anything that looked like that? Did you use E in anything you did? No. Stats is it's a whole thing, whole different world of everything. All right, so because I didn't want to put you on your computers again today,